This is Mr. Beck Does Your Homework. This is AP Physics Homework 4.1, question number 2. It says, an air puck of mass 0.031 kilograms, that's this one, is tied to a string and allowed to revolve in a circle of radius 1.1 meters on a frictionless horizontal surface. On the other end of the string, it passes through a hole in the center of the surface, and a mass of 2.8 kilograms is tied to it as shown. The suspended mass remains in equilibrium while the puck revolves on the surface. What is the magnitude of the force that maintains circular motion acting on the puck? Well, the magnitude of the force maintaining circular motion on the puck. What kind of force maintains circular motion is the centripetal force. So I want the magnitude of the centripetal force. Now, it's important in centripetal force problems and circular motion problems to figure out what real force creates this mathematical centripetal force. In this case, the reason this thing spins around is because of the tension in that string. It's the tension pulling in that string that allows that puck to move in a circle. So that tells me that the force of the centripetal force is going to equal the tension in the string. Now, this one's spinning around, so it's not in equilibrium, but this one is in equilibrium. So if I do a free body diagram of this lower mass, that would tell me that I've got gravity pointing down, I've got a tension pointing up, and these two must be equal because this is at rest. This remains in equilibrium, that means it remains at rest, while the top one spins around. So if the centripetal force is the tension, and in this case the tension is equal to the magnitude of gravity, then the centripetal force must equal the gravitational force. So I know that my gravitational force is going to be mass times gravity. Which mass? Well, it's going to be this mass, the 2.8 kilograms. So for me, my gravitational force is going to be 2.8 kilograms times 9.81 meters per second squared. And that's also going to be the centripetal force. So that is going to be the answer to question number 2. Question number 3 says, what is the linear speed of the puck? What's the speed of this thing as it goes around? So not the velocity, because the velocity is always changing, but what is the speed? Well, I know that the centripetal force is mv squared over r. If I'm looking for v, then I could rearrange, so I could have my velocity is the square root of, let's see, centripetal force times r divided by m. The centripetal force is going to be this number here. The radius is my 1.1 meters. Mass, what mass is this? Oh, that's the puck that's moving in a circle. So that one is my 0.31 kilograms. So that's the mass for this one. And when you do that, you get yourself a velocity. And that is the speed of the puck as it moves around the circle.